So, hello everybody, I'm Kevin and today I've got with me Alasdair. Alasdair's one of our designers and today we're going to cover one of our new products, which is our Kitronik air quality control hat for Raspberry Pi. You may know that here at Kitronik we are an authorised Raspberry Pi reseller. We've been doing that for a while now, so we have Raspberry Pi boards on our website and accessories from other people. But part of being an approved reseller, we've always been keen to actually develop some of our own products, which is what Alice has been working on. And this hat we're going to show you today is the first of those boards that we've created ourselves. So hopefully you'll find it interesting. We'll take you through some of the features of the board, all the features of the board. We'll then do some show you the kind of applications you could use it for. If you do have any questions, please let us know. We've got Mark manning the questions and answers, so you can just drop something in the stream and me and Alistair will do our very best to answer that for you. If not, this video will be live, be available on YouTube after it's been live, so you can always watch it back at your leisure. Okay, so shall we start off? So this is a air quality monitoring hat for the Pi.
Yes. So we're going to go through more of the technical details. We'll look through the hardware and a bit of how the software runs as well. But yes, this in essence is a monitoring board with various environmental sensors, but it's also got control features as well. So it's got outputs for servos and motors or other things you can connect. So it does both monitoring and output control as well.
Yeah, so you could make something happen
exactly
based on an environmental event.
Yes. Yeah.
Okay, great. Yeah, so yeah, this is we've launched this board last week, so we're quite excited about that. I can show you it now on our website, which is this one. Here we go. So yeah, if you go to our website, the product code is 5038. You can see that over here. It's a primarily Python-based board.
Yes, yeah, running with the Raspberry Pi. Yeah, Python works very well. It's native to Raspberry Pi, so all of our resources so far have been written in Python. Yeah,
and I guess people would expect that anyway, being a Pi-based product. Yeah, we recommend it's for age 14 plus, so that sort of period in school where people would be, probably getting proficient at Python coding if they're studying something like computer science. Or obviously for home hobbyists and things, there's lots of resources out there that could get them going. Yeah, so the products here, the prices vary depending upon quantity, somewhere between £36 and £31.50, exclusive of VAT. You can see that there. And then on this page we have lots of, we're going to go through these features in detail, but yeah, it talks about the features of the board, and then you have access to all of the support material, code examples and things like that off this page on our website.
Yeah.
Okay, we even got a video there, but
yeah,
we won't show that today. Okay, so should we take a closer look at the board and you can talk about the features of it?
Yes, I think that'd be a great start.
Okay, so just pop down to the next one down. Yeah, there we go.
Great. So you can see we've got here in the middle is the hat. I've also got, just for demonstration purposes, we've got a Pi 2, a Pi 3, a Pi 3A shape, and a Pi 4 and a Pi 0. And the hat, because it complies with the official hat specification, it will fit on and work with all of these Raspberry Pis that have the 40-way GPIO connector. So yeah, it's got all the various slots and cutouts and the right shape for being able to run with all of those.
So is that these gaps in the PCB?
Yes. If you just let me focus in, that's a bit better, isn't it? Yeah. So there's things like the slot just here for the display port, and you've got the cutout for where the camera connector would sit. If I pick up the Pi 4 and slot it in, see it fits on nicely, with then still being able to access the various connectors at different points and the debugging header as well. So yes, it fits on and complies with all those specifications, so it will fit nicely with cases or projects that are already, I guess you've already got for your Pi if you've got one before.
Yep.
Features of the board itself then, let's have a little look round. It's quite packed with things, so I'll try and go around and point them out. But that's the big key thing that makes it an air quality hat is it's got this BME 688 sensor just here. So that does temperature, pressure, humidity, an air quality index, sort of overall view using a gas sensor, and an estimated carbon dioxide level as well.
Okay.
So it's got all those 5 outputs.
So is air quality, I mean, I think this is proprietary to Bosch, isn't it?
Yes, it's a Bosch. It's called the IAQ, the Index of Air Quality reading. So it uses the gas sensor to look for a variety of like VOCs and other chemical traces, and then it gives this output figure to give you kind of a relative indication of how clean the air is.
And that's a number, is it?
Yes, so from like 0 to 500.
Okay.
The lower it is, the better. Or you can also output it as a percentage. So 100% air quality is good.
And you mentioned VOCs. What are they?
They're volatile organic compounds.
Okay.
So they're some of the things that, if you're like in your aerosols or in other kind of cleaning products, or perhaps in fumes from other processes or things going on in your home or in an industrial environment.
Okay. And a high number of those would indicate poor air quality, I guess.
Yes.
Okay.
So that's a great little sensor. It's a very small package, but it gives a lot of different readings and a lot of data that you can use to then, I guess, you're looking at your environment, or you can use various the outputs on the board. So there's a servo, and there's 2 then 1 amp high power outputs here, so you could be controlling fans or motors or all sorts of things that you could be doing, perhaps to then affect your environment to make it
like a water pump or something.
Water pump or a fan to get airflow going if things are if the air's getting stagnant.
Maybe a heater or something.
Yes, yeah. So it's got a lot of options there for then what you might control. And we've also got some nice onboard features for giving you notifications or feedback. So we've got a little OLED display screen in the middle. We'll see that in a demonstration video later. So you can put text or graphics onto that. It's just a simple black and white, but it means you can show some of your data readings live. And we've got some little zip LEDs. That's our fully RGB controllable LEDs that you could use for an indicator, perhaps of the air quality. If it's green, it's good. If it's orange, it's getting worse, and red is bad. So, but you can use those for anything. They're fully controllable, and a buzzer as well for some audio. We've also added to it, so the Pi by itself doesn't have a real-time clock, but we've used an RP2040 chip and a crystal to give you a real-time clock, so you can have proper time stamping of your data that you log. And we've also got some additional analog inputs here if you wanted to add extra sensors, perhaps something like if you're looking at soil moisture and you want an analog reading, or so those if you're comfortable with soldering, then there's some extra points here for adding additional.
So people
inputs.
Could put pin headers on those as an example.
Exactly,
maybe,
yes, and then you little jumper leads to plug in.
Okay.
So yeah, it's quite a lot packed onto there, and we've provided software to enable you to access and control everything. So we can go through that in a little bit more detail in a minute. But
can I ask? You know, obviously, if you've got those high power outputs and things, how do you power that board? Is it?
So all the power for this board comes directly through from the Pi GPIO header. So it uses the 5 volt and the 3.3 volt from the Pi. So this is a Pi 4 that I've got it plugged into at the moment, and that recommends about a 3 amp supply.
Oh well. Okay.
And that includes that's what's recommended for the Pi generally. So you've got headroom for doing things with hats that you plug in.
Yeah.
So each of these outputs would take an amp max, but not everything that you plug in would pull an amp.
Okay, so there's no need for an additional power supply for the board itself.
No. Once you're powering your Pi through its USB, then but make sure you've got the right power supply, I guess, for what your project you're doing. But yes, there's no need for additional power supplies to powering your Pi already. We felt that was a better way to do it, so that you've not got a faff of 2 power supplies or extra batteries that are going.
Okay, that makes sense. Yeah. And the high power outputs then they are just like on and off, aren't they? I'm assuming.
Yes, there is I think some PWM control, so you can do speed of a fan or a water pump, or you can just turn them on and off directly. And they've got little indicator LEDs to tell you when they're on. Okay. Little red LEDs that will turn on.
So it's good for a bit of debugging then if something's not working.
Yes.
Yeah, we like that kind of thing.
Yes, indicator LEDs are always helpful. It gives you. I'll just pop that down and refocus. There we go.
Okay.
Yes. And it works with all these. I put it on the Pi 4, but it works with all these others. We've tested it with all these different form factors of Pi, and it runs with them. So
pretty much most Pis out there, people will be able to use this hat with it then.
Yes, the only ones it definitely isn't is the original Pi 1 with the 26-way GPIO header. But I mean, we're on the Pi 4 now, so
yeah, you won't see many of those around.
No.
I'm sure there's still.
There's one kicking around the office, but we don't really use it.
No. Okay. Great, brilliant. So should we maybe talk about, I mean, the difficulty here is obviously we're not running the Pi itself, but could we show maybe how you would code this?
Yes, yeah, I think it would be really helpful if we looked at the, if we flip back to the, showing the, not that one yet, the window capture, sorry about that.
Yeah.
So on the website, we've already looked at a little bit, if we scroll to the bottom of the page, then there are some helpful links down in the resources section, and there is a data sheet for the product which gives you some details of perhaps which pins are used for what and power supply requirements, things like that. But then we've also got, on that first link is the library and example code. So if we open that, this takes you to our GitHub repo, and this is where we've stored the module and the library for controlling the hat. And there's a great README that details everything for how you want to set up the library with your Pi, and then all the various bits inside the library. I guess the key part here for installing, we've managed to put this, as well as being on GitHub, so you could look at the code directly. It's also on PyPI, so you can just use the pip install for Kitronik air quality control hat to, I guess, automatically run through that install process on your Pi.
So that gives you then the software libraries on the Pi needed to control.
Yes, it'll install. It'll download and install from, I think it's got the Pi wheel, directly onto your Pi. So it's all sorted, rather than having to download the code from the GitHub and then run an install process.
Okay.
So the instructions are all in here, and then once you've got it going, the README takes you through how to control the air quality sensor. That's the BME 688. And it gives you a little example program as well that you could run to just print out to your serial monitor on your Pi various data readings, then how you might go about using the OLED display. And yeah, this is all Python. It's all the library's made it really easy to access all the functions quite quickly and easily. The zip LEDs, that's those full RGB controllable LEDs for indicating various things. There's 3 of those on the board, and you can control each of them individually. The real-time clock, the analog inputs, the buzzer, and then we've also got some of those GPIO pins broken out as well. So you could be adding perhaps some extra LED outputs that you just want to turn like a LED on and off, or have some extra digital inputs if you've got other sensors that you wanted to add, if you wanted to expand the project beyond what's on the board already. And then those high power outputs as well. We've got turning them on and off, but you can also, as you've seen here, you can change the duty cycle. So you can have PWM control to change the speed or the brightness of something that you're controlling.
Yeah.
So there's a lot in there, but the GitHub repo is really good. The README is really helpful for taking you through that. And there are all the test programs as well in the example code folder up at the top. So if you want to just have some programs that were ready to go, if I open just one of them, this is the one for running the BME 688 sensor. You could just copy this across to your Pi and then run it, and then you'll be able to see how it's going.
Okay, that's going to display on the LED as well, though, isn't it?
Yeah, so display on the screen, and it will also print out the readings direct to your computer. So yes, there's a lot of helpful example programs, and I guess it all sort of a tutorial and going through each section. So that's the actual module itself.
So I guess obviously the point here is that you can have as much storage as you like on the Pi itself, so you could log an awful lot of readings, can't you? Really, it's not like a microbit or something where that memory is limited. I mean, there's no memory on that hat itself, is there? It's on the user Pi, I'm assuming.
No, you would. I'll just switch back to so you can see our faces. Yes, because you're using the SD card that's on your Pi itself. If you've got a big SD card, the more storage space you've got for doing data logging and leaving your project running for a long time. If you're doing monitoring of a particular environment, and actually that's something we can just show you. We did do a bit of a project just to see what the air quality and the environment was like just near our headquarters here in Nottingham, and we've got a blog post that we can run through there. Was that a question?
No. So we'll cover that in a little bit. So it's just obviously, for those of you who know, we're a UK-based company. So you can buy this board directly from ourselves. But we do have distributors all over the world. So if you're not based in the UK, or actually you maybe want to buy from a different UK company, we do have a list of people stocking this board aside from ourselves. We'll show those in a minute. So if people do want to purchase the board, there's options there. If I don't know, you're already buying from a different pie reseller, maybe in the UK or around the world, there's a number stocking these.
Great.
Okay. Should we, maybe I can bring that link up. Let me just do that now for we.
Yeah.
Were you going to go through this anyway, or?
No. Yeah. You can go do that.
Okay. Give me 1 second. Yeah. So this is our release sort of document, sort of release, sort of PR around the product. You can see here, so it's some graphics, and it talks about the board, and we've got some nice images showing you, in use, etc. And then down here we have a list of the companies that you can buy it for and store. They're already stocking it, and the country they're located in. So we've got our pie shop in Czechoslovakia. Got some here in the UK. We've got some in Canada, etc. If more are added, we'll add them to this list, so people can always find out where they want to buy the product. Okay, so
that's great.
Let's come back to ourselves. So what does he want to show next then? Is it the demonstration
So
video?
I think it'd be good to have a bit of a demonstration of how this was working, and a bit of a context of a little project that we went through. So we decided that it'd be good to monitor perhaps our environment over a couple of weeks where we're working, and I thought a great way to do that would be using the Pi and the Pi air quality control hat. So we designed and built a little case aimed to be a weatherproof, waterproof case that meant it's got a clear front, so you can still see your pie that would be stored inside. And we hung this outside the window of our office building, left it outside for a week or so to capture data, which we could then open in a spreadsheet and analyse and look at and see how our environment, what it's like.
Yeah.
And we put a blog post together, which I think would be good to show, and there's a little demonstration video as well in a minute. But if I just go, you can see this is a picture of the pie set up actually inside that box that I just showed you on the camera, and we had a little readout on the OLED screen of the temperature, pressure, the humidity, the carbon dioxide, the air quality, in a percentage, and an air quality score with that IAQ reading that's proprietary to Bosch. So we had that sat outside the window. This blog post that you can find along with all our blogs, I think it's in the coding tutorial section on our website. This has got how we went about designing a case, thinking about things like, because we're wanting to monitor the air quality outside of the box, we need to have airflow. So we had holes in the bottom, and then we installed a small fan to get a draw through of air to keep the air flowing past the sensor. That's quite important with the Pi itself, because the Pi gets quite warm when it's running. So that was also dual feature of a cooling.
So you don't want to distort your readings by the heat of the board.
It was adding quite a few degrees to the actual temperature. So we managed to level it out mostly by having a fan running when we were doing running the tests, and then we had various bits to stop rain getting in. And we even went and got, I think we showed a picture of testing it. Yes, we poured a big watering can full of water all over the pie, and we had some paper inside the box just to check whether any water would get in, and it remained dry. So we felt it was good to hang it outside the window and leave it out there for a few weeks. And we had it so that we could see through the window through the clear case and see that the pie was running. But once it was out there, we couldn't just keep getting it back in to download data. So we actually also wrote a web app, which I will flip to. So, I mean, this is also on another GitHub repo that we've got for this that you can access on Kitronik Limited, and there's also a link on the through this blog post tutorial. We've got this web app that we've written again in Python in Flask, sort of a Flask web app dashboard, and this way we could access all the data that was coming in from the sensors. And we could even send control outputs back the other way, so we could see when the fan was turning on and off for the high power output to keep that air and the cooling going. And I've got a little demonstration video just to show that running. So you can see you got the Pi running there, and what we're doing here is we're changing the color of the zip LEDs. You see we set it to be blue, and we flipped it, and we're going to set it to be green. change it back. We click update. So we could have this two-way control. We could have data coming in from the Pi hat that we could then store and then manipulate and use on our computer, and we could send controls back the other way. And all of that code for that web app is available here on the repo, and there's also the install instructions and how you run it as well. And this could be a great way for you to access your Pi as long as you're on the same network as the Raspberry Pi.
Okay.
Then you can just open this in any web browser, and then you've immediately got access to your data, and you can download it, and then you can use reused Excel to.
So you just need to be on the same network.
Yeah. That's what it is. And then we can download it and we put it in Excel and we plotted graphs of how things changed over time. And that was just all sitting outside the window and all controlled just from our desk.
Okay.
So the web app's a really good way of being able to.
And can you run that app on anything? Is it?
Yeah, so you could run it on. We had it on phones. We had it on.
Oh wow! Okay.
Because it's just as long as you're on the Wi-Fi network that the Pi is on.
Yeah.
Then you're fine to connect to it through any device that's got a web browser.
Okay, so you just literally go to an address, I guess.
Yeah.
Oh wow. Okay.
So, and all that information is available in the blog and on the GitHub repo for the web app.
So it seems really useful. So so this board could do lots of things. You could just monitor air quality or all the other things it can measure.
Yeah.
But then you can also act upon those results by making things happen. Like you might turn a pump on, you might turn a fan on, you turn a heater on, whatever you want to use it for.
Yeah, and as you're able to monitor the data over a long period of time, you could build in much more complex programs, I guess, with algorithms to do much smarter things for how you're and then affecting the environment with your control outputs as well.
It's just a case of writing that software using the functions in the library that you would.
Yeah.
Well, brilliant. That seems a nice product.
Yes, I think so. And I think it's got a lot of capability, so it'll be exciting to see what other things people do with it.
Yeah, so I don't know if there are any questions. Whether Mark can let us know if there's any. I can't see any so far. Maybe I'll just wait for an answer. We can So I mean, we do aim to do more hats in the future. But we go for that air quality. Something we've done for a long time, isn't it? We've done a board for Microbit, which is popular. We've got a air quality board for the Raspberry Pi Pico. So if people don't want to use a Pi, that's probably closer to this version.
Yes, because it's got the controlled outputs as well. This is very similar in functionality to the Pico version. But running it on the Pi particularly enables you to have that extra web connectivity and the much larger data storage options and a more powerful processor to run other algorithms if that's what you want to do.
Yeah, great. Well, I think just a quick message. Let's have a look at that one. See if there's any. So no, we don't have any questions at the moment. So I think we're not far off done. Is there anything else you want to cover?
No, I think I'm just going to say, guys, there's no questions right now. But as Kevin said at the start, as this video is going to be up on the YouTube channel, do feel free to post comments, and then Mark or one of us, and you can talk to the technical team as well, can get around to answering that question if you're watching this on catch up later on. Yeah,
absolutely, definitely. Is there anything that that we've not answered clearly, or other questions that pop up that maybe we haven't covered? Then please drop them in there, and we'll reply to you and hopefully give you an answer you can understand. But so obviously we do a lot of these tech talks. We're trying to do more of them. I'm hoping to do another one in a few weeks on another new product. So please keep your eyes peeled and look out for that. Hopefully you'll all find it quite interesting. It's another Python style product we're going to be covering. Quite excited to see you all again and show you some of the new products that we're developing here.
Great.
Okay.
Thanks very much, Kevin.
Yeah. Thank you, everybody.